All right, welcome back to Lag Demon Programming. Today we're going to do a little bit more work with the Raspberry Pi. We're going to look at how we can generate signals from one Raspberry Pi out to the GPIO and detect them on another Raspberry Pi and set up some very simple digital communication between them. So I hope you look forward to this little video series on Raspberry Pi, and yeah, let's go ahead and get started. We'll get started by hooking up the Raspberry Pis together with a patch line. That'll be we'll have to use the project board to connect them together, and I'll explain why when I'm doing that. But yeah, we'll do that, and then we'll start programming both the Raspberry Pis, one to send a signal, the other one to detect that signal, and we'll have them communicate. All right, test 1, 2, 3. Let me move this around a little bit. Test 1, 2, 3. Okay. All right, welcome back. So here we are over on our Raspberry Pi, one of our Raspberry Pis. We have two of them now. So the other one, I've changed the background so that I can easily tell them apart. This is actually a pretty cool looking background here. It's a little desert scene, black sand. So this is we'll just say this is Raspberry Pi 1, and this one over here are Raspberry Pi 2. This one here is Raspberry Pi 1. This is the one with the 8 gig of memory, and the other one's a 4 gig device. But that's not really going to matter for us. I want to start out by explaining that we're going to be writing a couple of small Qt applications using Qt Creator on here, and real quick I'm going to explain how you go about installing Qt on a Raspberry Pi. It's actually pretty simple. Here it's you want to do an update and upgrade of your system. Just make sure all of your packages are up to date, and then do sudo install Qt5 default and sudo apt install Qt Creator, or if you prefer apt-get get rather apt-get, or just apt works as well. It's pretty simple and straightforward. This is in the README file for the course repository, and the link to this course repository on GitHub will be, of course, in the description of the video. So we're good there. So here we are in this, and that was when I was just editing that. Let's start by firing up, well, actually, I started a project here, and maybe I'll, oh, no. Yeah, I started a project called GPIO. And really it's just a library project, and I'll show you how to create a project in, well, actually I show how to create projects in the Qt course, short course that I did getting started with Qt. So if you're not familiar with Qt at all, you might want to go watch those videos. I'll put links to those videos also in the description of this video if you want to go watch those, but I'm going to be covering Qt pretty thoroughly here. So let's fire up, oh, I did not want to bring up the browser. Let's shut that off. There we go. Let's fire up Qt Creator here, and I'm going to add that to my desktop just so it's a little easier to get to, because we'll be using it a lot. And so here's Qt Creator. A couple little settings I want to make. Tools, options, environment, theme, dark, apply. Okay, and I got to restart it. So let's restart it to reload that dark theme. I just prefer a dark background over a light background, especially for videos. I just think it's a lot easier on the eyes. It's a lot easier to see what's going on. So we've got this default last session here, and I don't understand why it never shows up as recent projects, but we'll just open it. Failed opening project. Oh, that's right. file. Huh. So what I did was I moved it. So let's go. Let's get out of this messed up project here and reload it. Yeah, so if you move a project, then of course it's not going to show up in here. So we'll just go open project. And I moved it into this projects, Raspberry Pi course, GPIO, and there's gpio.pro, which is the file we want to open as a project. So here we go. And what this is just a very simple library project for Qt, but we do need to add a library into this. So there's no GUI for this. This is just a library, headers, Unix. So what we need to add here is we need to go add new. No. We need to go add library is what I wanted. And it's going to be an external library. And I'm pretty sure that I installed it. So we're going to go browse. Well, actually, cancel this back. Is it a system library? It might be a system library. Library name, browse. Of course, it's still in here. We need to go up to here. And it's in, I believe, user, lib, and it's called pigpio, P-I-G, lib, pigpio.so. Open that. Next. Yep. Finish. And you can see that down here we have Unix Win32 libs -L pigpio. That should be all we need for that. So we've got some stuff here. This is a global one for defining, whether we're how we're sharing, how our shared library works exactly. And here's our main class called GPIO, which is what we're going to use to access the pigpio stuff. And so we're going to create a very simple library here to do some of the stuff that pigpio does. Let me just check and see how far along we are here on our video. And we are at, we're only 7 minutes in. Okay, we're good. All right, so, well, some of the first things that we want to do is using the pigpio library is be able to initialize it. So that's going to be in here. And right here in this, we're just going to call, well, we've got to include it. pigpio.h, and we want to go GPIO underscore, is it GPIO initialize. Now GPIO initialize actually returns a value. And so what we can do is go back here to our H file and let's create a private. Let's go up here and do it. And we will create, we're going to call it bool underscore initialized. I'm having a little trouble typing here. Equals, it'll start out false. And we'll go int init value equals -1. And what we'll do now is go back to here and we'll just go underscore init value equals GPIO initialize. Okay, so we'll get that init value and then we'll check it. So if underscore init value is greater than or equal to 0, then we'll set underscore initialized equals true. And now we just need some getters so that we can check things. So if we find, after bringing up our, after creating our object, if we find that it's not initialized, we can get that error code. So let's do this. Let's go bool is initialized, and we will return underscore initialized, and we'll go int init value, no, get init value, return underscore init value. Okay, and that's good for that. Now, there's a couple little things that I want to do here. One of those is we don't want to be able to copy this, so we're going to do this constant ampersand GPIO equals delete what's wrong with this constant GPIO ampersand equals delete, and then we're going to do GPIO ampersand operator equals constant GPIO ampersand equals delete. So between those two, there's no way to make a copy of this, and the reason for that is that we don't want a copy of this. It's basically a resource. We're creating and initializing our access to the GPIO system, and we only want one object to have that. We always want to initialize it so separately. So we could have multiple objects, I believe, talk to it. That's fine, but they've got to initialize themselves, and they've got to take care of that that resource properly. So we don't want a copy of this. That could cause problems, especially with some of our state stuff we're going to set up in here for talking to the GPIO. And generally speaking, we probably want only a single instance of this. So in actuality, come to think of it, we do always only want a single instance of this GPIO. So I'm going to make that private, and then I'm going to make a an instance of GPIO. We're going to go GPIO GPIO pointer. Actually, it's going to be static underscore instance, and we will have to create that over here. So we're going to make a singleton pattern basically, and we'll say this equals null pointer. Okay, and this has to be GPIO : instance. Okay, so that's a that's a static instance of this pointer to this, and what we're going to do here is found include, is it memory, right? And then we're going to go have a factory method here, very simple. We're going to go standard shared pointer GPIO get GPIO, and we'll go if underscore instance equals null pointer null pointer underscore instance equals standard make shared GPIO. Oh, no, we don't want to do that. We just want to go new. Oh, actually, that would probably be a good idea to just make it a standard shared pointer GPIO. No. Yep. Standard shared pointer GPIO instance. Let's go back to here and make this standard shared pointer actually GPIO colon instance equals null pointer. Okay. And back here to our factory, instance equals make standard make shared GPIO return underscore instance. Okay, so now we've got a factory producing a shared pointer for our GPIO instance. And the nice thing about this is when this goes out of scope, this will be this shared pointer will be destroyed when the application shuts down. So good. So now we can get it, whether it's initialized, get its init value if it isn't. So now we can test it. To test it, we'll just have to link to it. Since this is a library, we can't execute it. But what we can do is build it. We'll do a save all. Let's see if it builds. We get an error. What kind of an error are we getting here? What's the problem? Private in this context. Yeah. Oh, okay. Well, I have to go. We have to go GPIO pointer. We'll call it shared equals new GPIO, and then we'll just shared in order to give it what it needs. What the hell is that? Instant replay. Okay, I don't know what that is. Build, save all. Okay. All right, I'm going to pause the video for a minute and see what I'm doing wrong here. Okay, simple. So I had left when I changed this to do it based on an existing pointer because I've got this set up as private. I forgot to change make shared just to shared pointer. We're just creating a shared pointer out of that pointer and passing it back to the instance. It's always the same pointer, and we get a shared pointer from it. So we're good to go there. It's working now. We can compile. We get a green, so we've got a good piece. So. So some of the next things we want to do is we want to take. I'm going to pull up the web page here on the pigpio documentation, and I'll bring it over here. So there's really a whole bunch of stuff this does. These are the GPIO pins that it lists. Here, and so we're going to take a look at the C++ version of all of this, and I believe that's, well, the C library. Yeah, the C library, because we're kind of turning it into C++. That's connecting to the daemon. Okay, set mode and get mode and set pull down, set pull up, set pull up, pull down, set mode. So we can see here set pull up, pull down. We send in. So let's take a look at these. The set mode and get mode. Int pi is the I believe the what was returned by the pigpio start. So we got to pass that value in. That's our init value. So we pass that in. Then the GPIO pin, and then the mode, which is input, output, Alt 0, Alt 1, Alt 2, Alt 3, Alt 4, Alt 5. I'm not sure what those do exactly. I think they are for some different modes this can set. So let's start with those two, set mode and get mode, on an individual pin for our basic library, so that we can set the modes on the pins via our object here. So let's do this. Let's I'll put a comment here, GPIO control methods. So we'll have a let's double check that, make sure it doesn't return a value. It returns an int. So what does it return? 0 if okay, otherwise it can return some error codes. So the error codes here are bad GPIO, bad mode, pi not permitted. Let's create our own little error scheme for these so that we've got it more C++-ish. And what we'll do for that is we'll come up here and we'll go enum class GPIO errors. Paste these in. And if we have more errors, we'll just add them to this. So now what we want it to do is return GPIO errors. So instead of void, it's going to be GPIO errors. We'll call it set mode. We don't have to worry about the number value that we're going to pass in because that's recorded in our class. We'll pass that in. So what we want then is an int pin. And let's double check that and just make sure what those were exactly. I'm pretty sure they were int. Unsigned. Unsigned and unsigned. Okay, so let's set that then to unsigned pin and unsigned mode. And we could have our own modes. Probably be a good idea, because so what I don't want to do is ever have any dependencies out here on the header file on anything going on with pigpio. Pigpio is pulled in here in this, but we don't want it in the header file, so I don't want to use anything from there. So instead of just setting the pattern, what can we set on that? Let's go back to that. So these are the input, output, and the alts here for the modes. So what we'll do is create another one of these. We'll go enum class GPIO modes. Paste those in. Nice of them to put commas around them. Makes it easy to just put them in. Now we've kind of got our own modes. We'll translate these to those modes, and actually, we'll create a translator in our C++ file to change them into those unsigned values. So instead of that, we're going to have GPIO modes. Nope. Instead of unsigned, GPIO modes mode. There we go. And we don't want this. We'll do this in the we'll call this in the CPP file, and the reason we're going to call it in the CPP file and not here is we don't want to transfer a requirement for that header file to other systems. This is a library. It knows about pigpio. Nothing outside needs to know about pigpio. There won't be any reference to it anywhere in the header file. So let's do a get mode, and so we'll do let me double check that. I should pull that over here so I can have it to look at. I'm going to pull it over here so that I can look at it. I'll put the link to this pigpio documentation in the documents as well. Get mode, GPIO modes. Darn it. GPIO. Oh, come on. GPIO modes. Get mode. Unsigned pin. Okay, so we'll create those two. I don't know why this is doing that. Let me double check the time here. Don't want to make this too long. We're at 27 minutes, so I'll knock those two methods out real quick in the C++, and then we'll call it quits for this video, and we'll move on and do the rest of this in the next video. So let's go here to the, no, not that one, the CPP file. So pretty standard thing here. We'll create our two methods here in the CPP file, and it needs to be part of GPIO. That one and that one. And so we've got the pigpio, so we're going to go GPIO set mode. No, it's just set mode. Oh, it is GPIO set mode, so it's named differently than in this this one here. So this one only requires the GPIO. Oh, that's right. I'm on the wrong. I was showing you the wrong page. Well, it's basically the same thing. We don't have to pass in that because we're not calling the daemon. That's for those functions are for calling the built-in daemon, which we're going to do later. Right now we're calling the library directly. So we'll pass in the pin. But now for the mode, ping. This is the pin. We need this translator function for the mode. So I'm going to go back up to the header file here. I'm going to create some private methods down here. Private. And I'm going to go unsigned. We'll just call it translate mode, and it's going to be GPIO modes mode. Unsigned. We'll go here to the CPP file. We'll put this right here. GPIO : and we'll go case. No, we'll go switch mode case GPIO modes : input return GPIO what's it called, pi. We will return pi input pi underscore input. I don't know why it can't be this isn't supposed to be pi input. Oh yeah, it is. GPIO modes pi input. Okay. Well, little things that you got to remember. What we got to do is remove this pi from these. Or it will get confused over the library. It's really not supposed to, because this is supposed to be a class of its own, but we've got C header files involved, and that's what the problem is. So this is just going to be input, and we will return pi input. And so we'll do the rest of them real quick. How many are there? I don't remember. Oh yeah, it's the alt 0 pi alt 0. And how many are there? Alt 0 through 5, so there's 6. Go ahead and delete these. We'll just copy this one. Alt 0, 1, 2, 3, 4, 5, 6. Alt 1, Alt 2, Alt 3, Alt 4, Alt 5. Too many. Alt 0, Alt 1, 2, 3, 4, 5. And then we got one more. Should be output. Output. And that should be pi. Output, and now very simply we just go translate mode, and so there's that one. And what we're going to do is GPIO set mode. Does it return an error? It does. Actually, now we have to translate the errors as well. So that should be fairly simple. There's only 3. So we'll go int translate errors GPIO errors error this this in here. This switch error, switch error, case GPIO errors, colon, bad GPIO, colon, return pi underscore bad underscore GPIO. Case GPIO errors, colon, bad mode, colon, return pi bad mode. And case GPIO errors, colon, not permitted, return pi underscore not permitted. Actually, I got that backwards, didn't I? So, well, that's good. We do need that probably at some point when we want to translate them that way, but we need another translate errors. So we might as well not throw that away because we will need it at some point, but what we need is one that returns GPIO errors but takes in an unsigned error. And now we'll just go back to here and we'll grab this, copy it, paste it. We'll reverse this. We'll put this here. We'll make this unsigned. And this is going to be pi underscore bad GPIO colon return that. And get rid of this. Return why doesn't it well, this is supposed to be unsigned. GPIO errors, translate errors, unsigned error. Okay. It's supposed to be pi bad mode colon return this and get rid of this. And this is supposed to be case pi not permitted. And I think this is not supposed to be unsigned. This is supposed to be int. And this is supposed to be int because these are negative numbers. Colon return that and get rid of this. And return. There we go. And so what we're going to return, translate errors, this, all of this. And why we get the extra things in here? Translate mode. Translate mode, GPIO set mode. The mode is an unsigned int, so this is actually supposed to be. Oh, no. That's fine. It's translate mode is supposed to be unsigned int. Unsigned int. Cannot initialize parameter of type. What's it saying here? Come on. Mode. Translate mode. GPIO set mode pin unsigned int. Cannot initialize parameter of type GPIO modes with R value of type int. Mode. GPIO modes is a mode. Translate mode. Returns an unsigned int. Translate mode. Oh, this is supposed to be translate errors. Damn it. Translate errors. Okay. Now we got it. Now we're going to do translate mode. GPIO get mode pin. And I know this video ran a little bit long, so in the next video we'll set up a little test for this and make sure that we can get and set the modes of these pins, and we'll be setting some other stuff as well, not just input output but pull up, pull down, and so forth, and we'll get this all lined up in this C++ library that we can then call upon to do these functions. So that's it for this video. Thanks for watching. I hope you enjoyed it, and if you really liked it, hit that like button. If you want to subscribe, we really appreciate subscriptions. They help us a great deal. And if you have any questions, leave a comment in the comment sections, and I'll be happy to answer it. I always look at comments, and I will see you in the next video. Thanks for watching.